The chemical formula of a compound is a symbolic representation of its composition. The chemical formulae of different compounds can be written easily. But for this, we should know the symbols and their combining capacity. We have studied symbols of elements. Let us now learn about the combining capacity of elements. The combining power or capacity of an element is known as its valency. Valency can be used to find out how the atoms of an element will combine with the atoms of another element to form a chemical compound. Let us understand valency by an example. Imagine if an octopus is to hold some humans in such a way that its 8 arms are used with both arms of humans, how many humans can an octopus hold? If we represent octopus as O and humans with H symbols, can you write a formula for this combination? The octopus can hold up to 4 humans. Therefore, we can write its formula as OH4, where 4 represents the number of humans captured by the octopus. Here, you can see the valencies of some simple and polyatomic ions. Let us now look at the rules for writing chemical formulae. 1. The valencies or charges on the ion must balance. For example, the formula of hydrochloric acid compound is HCl, where the valency of both hydrogen H+ and chlorine Cl- is 1, which is balanced in this formula. 2. When a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. For example, calcium oxide, CaO, where oxygen is non-metal and is written on the right, whereas calcium is metal and is written on the left. 3. In compounds formed with polyatomic ions, the number of ions present in the compound is indicated by enclosing the formula of ion in a bracket and writing the number of ions outside the bracket. For example, the formula for ammonium sulfate is NH4 2SO4. Here, the number of polyatomic ions ammonium NH4 plus is 2. So, we write it in a bracket. Similarly, if the number of polyatomic ions is 1, such as sodium hydroxide, NaOH, bracket is not needed here. Let us now practice writing the formulae of various compounds. First, we will see some examples of writing the formulae of simple compounds. The simplest compounds formed from 2 different elements are called binary compounds. For example, when writing formulae for molecular compounds such as hydrogen sulfide, we first consider the constituent elements hydrogen and sulfide. We can write their symbols H and S and valencies 1 and 2 respectively. After that, valencies of compound atoms can be written by crossover, such as H2S. But if the compound is composed of ions of different elements, then how shall we write its formulae? Let us understand this by an example. Magnesium chloride compounds are formed by combining magnesium Mg2+ and chloride Cl- ions. To find its formula, we write the symbol of cation Mg2+ first, followed by the symbol of anion Cl-. Then their charges are crisscrossed to get the formula, that is MgCl2. Thus, we see that in the molecule of MgCl2, that is magnesium chloride, has 2 chloride ions Cl- for each magnesium ion Mg2+. Note that in the formula, the charges on the ions are not indicated. Let us now look at some examples of writing the formulae of a compound with polyatomic ions. We do not use a bracket when there is only one ion present in a compound containing polyatomic ions. For example, in one molecule of sodium carbonate, there are 2 ions of sodium ion, Na+, having 1 atom, and only 1 ion of polyatomic carbonate ion, CO3, 2-. Therefore, we do not use brackets for the polyatomic ion CO3, 2- in its formula Na2CO3. When the formula contains 2 or more ions of the same ion, we use brackets for them. For example, the formula for calcium hydroxide is CaOH in bracket 2 and not CaOH2. Here, the bracket around OH with a subscript 2 indicates that there are 2 hydroxyl OH groups joined to one calcium